Well, hello Internet, and welcome to part 3 of my C video tutorial. Today I'm going to talk about the switch statement, arrays, strings, functions, and a whole bunch of other different things. And if you missed any of the previous parts of this tutorial series, I provide a link to the playlist in the upper right hand corner. So I have a lot to do, so let's get into it. Okay, so I'm using the basic setup I had before, basic text editor, text wrangler, Notepad++ if you are on a Windows machine, terminal or command line if you are on Windows as well. And I have my basic standard IO library and another standard library that I'm going to require because I'm going to show you how to use the exit statement, which is going to allow you to exit completely out of a program from anywhere inside of your code. And basically, to show you the importance or the niftiness of the switch statement, I am going to create a basic menu system, and since I have no idea how many times I'm going to have to loop, I'm going to use a do while loop, mainly because people are always asking what is the purpose of do while. And of course it is whenever you need to do something absolutely one time, and then you may not have to ever do it again. Okay, so I have my basic print statements inside of here, and this is a basic menu system. It's actually not really going to do anything, but it's good nonetheless. And I'm going to throw in 2, and it's just going to allow the user to ask different questions and provide output. And then finally it's going to be quit. And then I'm going to throw scanf in here. I'm actually going to show you another way to accept input in a less volatile way than using scanf in this tutorial as well. Here is the pointer information, which I'm actually going to cover in the next part of the tutorial. And then finally, we're going to come in here at the end and we're going to say while. And I'm going to continue showing this menu over and over and over until they give me input that is a 1, 2, 3, or a 4. So how exactly would I do that? You can pause this for a second if you want to think about what my conditional is going to be. But what my conditional is going to be is I'm going to say what to do. This is going to continue looping as long as what to do is less than 1 or what to do is greater than 4. So as long as either one of those is true, this is going to loop forever. Well then, what exactly are we going to do in regards to handling whenever they enter a 1, 2, 3, or a 4? Well, I'm going to show you what it would look like if we used an if statement. And then I'm going to show you how the switch statement is going to improve on that. So I'm going to say what to do if a 1 was entered, and in this situation, and I'm just going to say print the time. There we go. Then what I'm going to do is have to copy this and say else, and then I'm going to go in here, paste else if, put another else if inside of there, and then I'm going to say 2, and then I'm going to say 3. And then finally, there's only one option it could be, which is 4. Otherwise, it wouldn't have passed our little condition we had. Else, and I'll put that in there, but I'll just get rid of this if statement here at the end. And then I'll come up here and just say print the date, print the day. And then this one, I'll just say bye-bye because that was the quit option. And then just to show you how to exit out using 0, which means that it's a non-error causing exit. Just type in exit with a 0 inside of there. And that's going to exit out of your program altogether. And I got all the braces all set up here, and all that looks like it's good. So let's file save it. And I'm going to be using the standard C99 version for my compiler, like that. And then let's test this. What day is it? Let's type in a 0. You can see it asks me for it again, and then I can type in a 3. And you can see it prints the day on the screen. So that's basically what it does. And the if statement does indeed work. But if we look at the switch statement, you're going to see that it's a better solution for this problem we have. Now basically what the switch statement's going to do is it is going to check the value for the actual variable that is provided, which is going to be what to do. And it's going to have curly braces just like most other things. The only thing is here is this must be either a character or an int that we are checking here. And then what we do is we say case they entered a 1, what are we going to do? Well, we're going to say printf print the time, like that. And then what we're going to do, I'm going to just pop in here, is say break. Now, unless you want to check the next case, which is going to be this guy, and that's going to handle a 2, this is going to handle a 3, and this is going to be what we call default. The way switch is set up, remember I said the if statement, if one condition is true, it doesn't bother to check the other ones for whether they're true or not? Well, the switch statement keeps on asking, unless you put break. That throws you out of the switch statement. So here we'll say print the time, print the date, print the day. I think those are right, yes. And then here, default, bye-bye. And then we're going to also put exit inside of here. And if I did all that right, it's going to work in exactly the same way. Looks like I did. You can see what time is it, what's today's date, da 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 da. 0, it's going to ask me again, and then I'm going to type in 4, and it is going to say bye-bye, da-da-da-da-da. So there is the switch statement. As you can see, it's much neater for this situation. So if you need an int or a character, and you're only going to be checking one value, look how neat it is. Very, very nice. Now on to our next program. Next, what I'm going to talk about are arrays. Now, we've already talked about arrays in regards to a string inside of C is actually a character array. But I just wanted to point out a couple simple things. Like, for example, the very first piece of data that we put into an array is going to be an index 0. This is just a number that is going to tell us in which box inside of the array we are in. Second one's going to be 1, and then it's going to be 2, and 3, and 4, and 5, of course, as big as your array is. Now, you can initialize your array like I did here with the 2, 3, and 5, quite simply with prime nums, 3 inside of it, and then define exactly what's going to go in each box. That's all an array is, just a big bunch of boxes. I can also come in here, since I am defining what data is going in there, I actually don't have to determine or provide a size. I can just leave that area in the brackets blank. So let's look at that in code. So here we are, I got a main again, just like before, and I'm going to create right now a printf statement there, and I'm also going to create myself a character array, and I'm going to put in whole name, and I can type in 12, and remember we're going to have to leave space for null after our string. So if you add these up, that's going to be 5, that's going to be 5, that's going to be 1, and then the null at the very, very, very end, that equals 12. Now, it doesn't always, and it actually almost never makes sense for these to be exactly the right size, as we're going to get into in a second here. And the null, by the way, is this guy right here, that dash, and then the 0. But for now, that's how I'm going to define it. Like I said before, you can also come in here and define exactly what data is going to be inside of there, and you can also define a size if you want, and you put the little curly brackets, and you're going to say something like 2, 3, and 5, like that. Another way to create and put different values inside of an array. And like I also said, more primes. If you're defining the data that goes inside of it, you do not need to actually put a size. You can just go in there and put things in, and it will automatically size the array for you. Also, like I covered, if we want to actually come in here and check what the first prime in the list is, you come in here and just put a D, because that is going to be a decimal. And then what we can do is go prime nums, like that, go to the 0 index, like that, and of course make this prime numbers, sorry about that, then bounce over here, compile that, and execute it, and you can see the first prime in the list is 2. So there you go. 0 index, like many other languages, if you're aware of other programming languages. We could also come in here, even though this is a little bit silly, and define a character array in exactly the same way. You're going to see why this is silly. So let's say I wanted to say Chicago. This is how I would have to come in here and do it, and just keep on going on. Just imagine that I typed in all the letters required for Chicago, because that's silly, and the reason why is because I can also go in here and type in character, third city, and say something like Paris, da-da-da. So there's no real point in doing this. Another positive of doing it this way is whenever you create your character array this way, it's going to put in your null character in here in the last position. And if you would type in Chicago like this, you'd actually have to put that in yourself. So, you know, equally silly. So don't do this. But I wanted to show you that you can do it, you know, because why not? Now, whenever we are creating arrays, like I said before, everything is just a whole bunch of boxes. And one of the reasons why we're going to do away with scanf is because scanf, and we're also going to do away with string copy, which I talked about previously, which is very, very bad. Once an array is going to be defined, we're going to actually be able to go in and change the values with things like string copy, for example. The only problem with that is if you have 2, 3, and 5, and you enter in 2, 3, 5, and 7, it's actually going to potentially destroy or overwrite other important stuff in memory. That is a definite possibility. So I'm going to show you a different way to actually work with arrays and eliminate that issue. And it's also very, very important to make sure your arrays are big enough to hold all the potential input that would go into it. But of course, you're going to not want to make it too large because you don't want to consume a lot of memory. So it's sort of like one of those things where you're going to have to make a judgment call on your own. So we come back into our coding world here. So let's say I want to allow them to enter some sort of input, and it's going to be a city name, and I've decided at this point that 30 is big enough, even though we're going to find out later that it isn't. And I'm going to say, what city do you live in? Now, the reason why we're going to want to get rid of scanf is because scanf, like I said before, is going to allow you to overwrite data past the end of our space that we have allocated inside of our array. Scanf is not smart enough to know not to do that. Also, as we've seen previously in the tutorial, it's also not going to allow you to enter spaces unless you define exactly where those spaces are going to lie, and then pull the information apart and throw it into two different variables. Also, on top of that, scanf is very, very big and bloated. So what we're going to use instead is something called fgets. What makes fgets much better is it has neither of the problems that you will find using scanf. And on top of that, it's also going to add in your little null character at the end of any of your strings that you put inside of it. And really the only negative with fgets is that you must provide a size limit for the data that's going to be entered into your string. So we're going to come in here and go your city. Then we're going to define the size for it, and then standard in, which is going to be your keyboard. And then we got that data, and we're going to say printf. And I'm going to show you a whole bunch of other different ways to input and output data later on. And then we're going to say your city, compile, execute. What city do you live in? Pittsburgh. And boom, hello Pittsburgh prints out on our screen. So there you go, that's super duper. Now really another thing that I forgot to mention about fgets that's not exactly the best thing is as I was typing that information in, when I typed in Pittsburgh, what did I have to do at the very end? I had to put in a new line because I hit enter. Well, with fgets it's going to make a lot of sense to get rid of that. So let's just go in there and get rid of it. And I'm going to be initializing this inside of the for loop. That's why I'm using the 99 version of C. And as this tutorial continues, I'm going to be using that all the time. And then I'm going to get into some of the things that are in the 2000 version of C. So what I can do is I can say if your city, basically what I'm doing is going through all of the different parts of the array, all the indexes starting at 0 for our array. And I'm going to say if this index contains a new line, well, in that situation, I want to go your city, and you're also seeing here how to change the value that's in an index, and I'm going to put my null character in there instead. And then to keep it from continuing to loop after it finds that, I'm also going to throw a break statement in there. Now, I'm going to take this exact thing up here, and then after the for loop, print it in there, and we're going to see the difference. We're basically going to see that the new line goes away. Compile it, execute it, Pittsburgh. Hello Pittsburgh. See, there's not as many new lines here as there is there. So that's basically all we did, but it's very useful nonetheless. And I'm just going to continue in here writing some code and go over a couple other different string functions that are available to you. Now one of them is string compare. What it's going to allow you to do is it's going to take two strings and it's going to return a negative number if the first string is less than the second. It's going to return a positive number if the opposite occurs, and it's going to return a 0 if they are equal. To use it, we're going to say printf, and I'm going to say something like, is your city Paris? And then here I'm just going to print a result, and then we can use string compare and put your city, and then we can put third city, which is where Paris is stored. And to use this guy, I'm actually going to have to come up here and throw another include in, paste that in there, and then type in string. And then we can come in here and compile it and execute it. What city do you live in? Pittsburgh. Hello Pittsburgh, blah blah blah. Your city is your city Paris, and it spits out 8. And the reason why it spits out 8 is because my first string, being Pittsburgh, is indeed greater than the second string being Paris. Or to put it other ways, Paris would come first if everything was in alphabetical order. So that's string compare. And of course, you should go and play around with these different things till you get used to them. Another thing you can do is you can add a second string to a first string, which is called concatenation. But if you just prefer append, that's perfectly fine. But it is called concatenation. And to do that, you're going to use another string function called strcat, or string concatenate. And let's say that I want to put Pennsylvania on the end of my city name. I can say string cat, and then just type in your city, which is going to be the first part of this new string, and whatever you want to add to it. And then I could say you live in, and it's going to return a string, your city. Just remember that this isn't a temporary thing, this is permanent. Now your city is going to have the full name. And there we go. Pittsburgh, blah, 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 blah. You live in Pittsburgh, Pennsylvania. See? There it is. So there's another function for you. Another thing that is very useful for strings is string length. And it's going to do exactly what you think. It's going to return the length of the string minus that null character at the very end. So just the letters. So letters in Paris, D, and then a bunch of new lines. And to get the length of the string, we're just going to type in strlen. And let's just say third city this time, which is going to be Paris. And of course, put this brace inside of there. Save, execute. Letters in Paris, 5 comes up. And then the final thing I'm going to show you is in reference to not using string copy. Remember, we're not going to use string copy because it can overwrite other parts of memory. So if you want to use something that does pretty much exactly what string copy does, but in a safe way, then you want to use strlcpy. So if we wanted to print out your city, and let's say it is a city that has a very, very long name. And yes, this is a real city name. Well, what we're going to have to do with this new guy that is much better than string copy is provide the size for it. That's it. That's the only other thing, and then we don't have to worry about overwriting different parts of memory. And then if somebody tries to print it out, let's say something like new city is string your city, like that. Of course, make this an uppercase C. Mouse over here and execute it. New city is El Pueblo, da 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 da, and you can see that it cut off the Angeles part at the very, very end of it. And if you count all this up, it is going to be equal to 29 different characters. So you can see it just basically, if it enters more information than you can fit in, it just cuts off any additional information that is entered into it. So that's all very, very, very useful information. So now let's go and write ourselves another program and talk about global variables, local variables, functions, and a whole bunch of other things. Now, a global variable is going to be a variable that is going to be seen, or every function will have the capability to see this value and change it. And I'm just going to type in global var. You can type in anything. You could type in C. That's just the name. That doesn't have anything to do with anything other than that. And give it a value of 0. Now, any function that you create, and yes, there can be more functions than just main, of course, is going to be able to access this information. We just have to put it in a position where it is not inside of any other functions inside of your program. And that brings us to functions. Now, what this function is going to do is it's going to receive two different numbers, it's going to add them up, and it's going to return the result. And each function that you're going to create is going to have a return type, and if it doesn't, we're going to have to put void at the very beginning, like I've been doing with main here all along. But this function I'm going to create in a second is going to actually return some information. And so there is going to be the type, the data type value that is going to be returned. And I'm going to say add two ints. Then inside of here, these are going to be attributes. And you're going to have to define the data type for the attributes that are going to be passed inside of this function. And then this function is going to do something really simple. It's just going to return number 1 plus number 2. That's it. And of course, we're going to need functions inside of C if you ever want to make any type of program that is big in any way. It's almost impossible to make a complex program in which everything's going to be inside of main. And in regards to what is a function, you're basically going to want to turn any task, any calculation, pretty much anything into a function inside of C, and then have main call the function. And you want to make the main part of your program be as readable as humanly possible. And to use this function, we're just going to go int total is equal to add two ints. And then we can pass in any integer inside of that guy. And then, of course, we can say the sum is, and of course, it's going to be an integer itself, and total, and execute. You can see the sum is 9, of course. So that's basically how functions work. Now we're going to get into the difference between global and local variables. Now this comes up even to this day. Just today I had somebody ask me a question about local variables versus global variables. Like I told you before, if it is a local variable inside of C, without pointers, you basically are stuck. You're not going to be able to do anything with that data. As you're going to see later on, with pointers, you're going to be able to go into memory and access from any different function. But inside of C, basically every function you create is going to have access to this guy right here, but the local variables, the variables created inside of a function, are only going to be there. So inside of here, what I'm going to do is I'm going to create a local variable, which everything created in the function is going to be local, and it's going to be age is equal to 10. Then what I'm going to do is I'm going to go and get the global variable that anybody can change and change the value for it to 50. I'm then going to say age before a call to the function, and I'm going to call another function is equal to the, and then print whatever age is. And then I'm going to do exactly the same thing with the global variable. And here I'm just going to type in global var like that, and global var again. Then I'm going to call an outside function, which I haven't created yet, and it's just going to be called change variables. And you don't have to pass an attribute, by the way, if you were wondering. And then we're going to come up here and make sure we do this up here ahead of main. Want to make sure all your functions are created before you call main, because the way C works everything out, it assumes that every function is going to return an int. So if it comes down here inside of main and it gets to this point down here where he has change variables, and then I go up here and I actually define this guy as void like that, it's going to throw an error because it's going to say, hey, wait a minute. Remember, all the execution starts in main, so it's going to say, hey, wait a minute, change variable's an int, because I always make everything an int if it hasn't been defined before I see it. So if change variables was down here, that's going to throw an error, okay? So just wanted to point that out, because that's another funky, weird thing with C. So inside of this guy, remember, we have age down here. There's age. Well, up here I'm going to say, all right, well, I want to change age as well, but I have to define it inside here. What this is doing is creating a new local variable that is local to the change variables method. It has absolutely zero effect anywhere else. However, if I print this in here and I say age inside of function, and then put age inside of there, it's going to print out 40, as you're going to see here in a minute. Then what I'm going to do is go global var and set the value for it to 100. Change variables can do that and can affect the global variable, as you're going to see in a second. So then we're going to come down here like that, and instead we're going to say global var inside a function and global var inside a function. Then come back down inside of here again, and we're basically going to do the same thing, except we're going to say age after a call and global variable after. And if I did everything right, pop over here and execute. And you're going to see age before a call to the function is going to be equal to 10. Okay, makes sense because that's what this is right here. Global variable for a call to the function is going to be equal to 50. Makes sense because that's what I set it there. Age inside a function is going to be 40. Okay, because I set it to 40 here. But remember, that's a local variable. That's not the same age. Global variable inside of the function is going to be 100. Why? Because I defined it as 100. Age after a call to the function, however, is going to be 10 because nothing changed. I was not using this variable. I was using the variable that was local to the change variables method. And that is a whole bunch of stuff about functions, global variables, and everything else I covered in this tutorial. Up next, I'll be talking about pointers. Please leave your questions and comments below. Otherwise, till next time.